Hey there, my name's Drew Brashler, and in this video, I want to show you how to solder and fix an XLR cable. Now, if you're brand new to my channel, I'm all about helping you feel more confident with your production gear no matter where you're starting from. So let's go ahead and dive in. Now, we've all had it. We've had an XLR that just doesn't work. Now, that can be for a number of different reasons. It could be that the cable itself is just severed in the middle, where some of the connections aren't working, or it could be that some of the connections are actually bridging together when they shouldn't. And so in this video, I want to show you a global overview of actually how to solder and fix an XLR cable, or just solder a cable from scratch, from the get-go. Now, there are a couple things that you need to have to be able to solder a cable correctly. And it all starts with a soldering iron. Now, you can get any soldering iron out there, but this is the Pine Sol made by Pine 64. And this is a fantastic soldering iron because it has a USB-C on the back or a little DC plug. Now, this can be powered off of a standard USB-C power supply that you'd use for your computer, like a 65 watt or lower. Now, the benefit of this is you can have temperature control, and it's pretty inexpensive in comparison to all the rest of the soldering irons that are out there that also have temperature control. So this is my choice of soldering iron whenever I'm traveling on a gig or even when I'm soldering at home. So this is a fantastic soldering iron. Now, the next thing that you need to have is a pair of diagonal cutters and a knife. Now, the diagonal cutters are important because these let you cut your cable, and you can even strip cable with these. Or you could go ahead and get a set of small wire strippers. Now, the wire strippers have a convenient portion in that you can actually strip the wire size that you have in your XLR cable, and you can cut it. Now, the other thing is I talk about a knife. Now, I always use a knife when I'm stripping off the jacket that's on our wire. Now, I'll be showing all of this to you here in a little bit, but having a very sharp knife is important for when you're soldering. And so my tools of choice whenever I'm soldering is a very sharp knife and a pair of diagonal cutters, or if I happen to have a pair of wire strippers, I'll use that, but sometimes in my Pelican, I can't have all of this stuff. So I will typically have just a pair of diagonal cutters and a sharp knife. Now, the other thing that you need is solder. And so I typically have a leaded solder. Now, if you don't want to be working with lead, you can get a non-lead tin solder, but the leaded solder is usually easier for soldering if you're brand new to soldering. So after you solder, just make sure that you wash your hands correctly, and it's okay. The other thing that we have here is a wire cleaning pad. Now, this is a copper pad. This is just for like scrubbing pots and pans, and I use this for cleaning the tip of my soldering iron, and I'll show you guys that here in a little bit as well. Then the other thing that you need is XLR plugs. Your XLR connectors. I have a male and a female here, and I also have an older Switchcraft style XLR where it has these screws. Now, if you are in an older church, chances are you have a ton of these, and these are a bit of a pain to get apart and working if you happen to come across some old ones. So I will show you how to get that thing working, but usually I will go with Neutrik XLR connectors, as that is the best that I like. Now, the other thing that you need is a XLR tester. This is going to verify that your XLR cable is correctly connected. Now, you can also just use a multimeter, and I have my multimeter here, so you can just verify your pins are connecting to the correct pin and that they are not bridged, and I'll also show you how to use it with that. Now, the very last thing that I like to have is a piece of aluminum foil. Just a piece of tin foil. And because this is what I typically will solder on. And so all I have is just this piece of tin foil, and I'll take it and I will fold it in half, like so. And I'll typically fold it in half again. Now, why? Well, aluminum is a very good conductor of heat. And so you can cool things down quickly with this. Because soldering is hot. When you're using a soldering iron, it is exceptionally hot. And so I will always solder over top of this, one, to protect the table, and sometimes I'll put a piece of cardboard if I'm on a nice table that you definitely don't want to get dirty or damaged. But I will always solder on a piece of tinfoil because it is easy to throw away. If you drop some solder on it, it's not that big of a problem. But then also I can use this as a heat conductor to cool something down if I need to, handle it with my hands. So I'm going to grab my other camera, get it set up on this table here, and I'm going to show you how to solder. Okay, so I have my cable tester here. Now this is the Behringer CT100. I find that this is a great cable tester in that it has a little intermittent light. So what's great about this is if you turn this on to cable tester, you can go and plug in your different XLRs into this, and you can reset this and then wiggle things around and make sure that you don't have any cables that are accidentally being unplugged for a second. And so if I was to go ahead and scoot this thing back just a little bit, it would break the connection on one of the cables. And so we can see that our intermittent lights just came on, showing that this would be, in essence, a bad cable. Now, if we have a bad cable, then what we need to do is we want to find where that cable is broken. And chances are it's going to be in the connector itself. Now then the other thing that you want to do is you want to go over that entire cable and look over the jacket or this portion of our cable and make sure that there's no kinks. So if you have a kink that's really bad, for instance, like that, sometimes what can happen is the conductors inside would bridge together. And so if you have a cable where it's showing that a bunch of your pins are bridged together, then chances are the cable might be bad. In which case, you can just go ahead and take some cutters and cut out that section of cable and just shorten your cable, or turn it into two pieces. Or if you just need to replace a connector, that's pretty easy. So this is a Switchcraft connector. It's an older style connector, and you can find that it's a Switchcraft connector by these little screws. Now, there are 3 screws on a Switchcraft connector. There's this one, which is missing, and then we have this one, and then we have that one. Now, with a Switchcraft connector, these 2 screws at the back right here are for the strain relief. And so to get this apart, you need to have a screwdriver. And so I have my screwdriver here, and got to find the right size flat head. So there we go. And I'm going to toss that on here. And once we have that, then we can go and loosen up this connector. And so these you can either choose to pull out all the way or just pull them back slightly. And then this screw is actually for these pins that are right here. And so if I go ahead and unscrew, this will actually go back into the connector. So you can see that this thing is going deeper and deeper into it. So it's a reverse thread, but it works the correct way. If we are unscrewing this, it's going back into the body. Now at this point, because I have my strain relief backed off, and this one's missing, and then I have put that all the way in, I can take this cable and I can push it out the end of this connector. And so then we can see that I have my connector here that I can go and solder. Now, this is a correctly soldered cable, so I don't really need to do anything with this, but I just wanted to show you how to get a Switchcraft connector open. Now, once you've finished soldering, what you have to do is you have to line this up with this little tab that's right here, and there you can see that in the light, and this will then line up with the connector, and you will pull this all the way back until you see that screw lining up with this hole, and so you can see that that's too far out. Once it's lined up with that hole, you'll take your screwdriver and you'll go clockwise, and it will come back out into that spot. And then once you've done that, you need to go ahead and tighten your strain reliefs. And so the strain reliefs on this connector you'll have to do at the same time. So then go ahead and tighten one, and then go above it to the other, tighten that, back and forth and back and forth. Now the other type of connector is a Neutrik connector. Now this is an off-branded Neutrik connector that I just found in my garage, so we're just going to be using this today. Now the benefit of these connectors is that the strain relief is built into this butt portion of this connector. It's just screwing in. So if we unscrew this all the way, we will find that there is a strain relief right here, and we can see that these little 3 things grasp the cable as this is tightened down. And then if we look in here, that is where our connector is. And so what we can do is we can just grab a pencil or a screwdriver and pop this thing out. Now, this is a female XLR, and here is the male XLR of this same type of connector. And so I'm going to pop this out, and so we can see here is the male, here is the female. Now, one thing to note about these is that as we're looking at this, we can see little numbers. Now I'm going to go ahead and zoom in just a little bit more so you can see this. So you can see that there is a 1, a 2, and a 3. And on this one, we can see a 1, a 2, and a 3. Now that stands for the pins on our XLR. Now when we put these two together, the pins line up correctly. Now when we are soldering this, pin 1 is our ground, or the shield of the connector. Pin 2 is the positive of the connector, and pin 3 is the negative of the connector. So with an XLR, it is a balanced signal. So we have a positive and a negative invert of the same signal. And so that's what the positive and negative is. So positive is number 2, negative is number 3, and the ground is on 1. Now, if you have an unbalanced signal that you're wanting to put into an XLR, what you would do is you would take the positive of that unbalanced signal and solder that to pin 2. And then you would take your ground of that unbalanced signal and you would solder that to pin 3 and pin 1. So we would connect that to both pin 1 and pin 3. Now by doing that, you are taking your unbalanced signal and plugging it into a balanced input, but it's grounding the ground and the negative invert. So it's just going to reference it as a normal unbalanced signal. So I know that that was a lot. That's how you can do some soldering for getting an unbalanced signal into a balanced input, or likewise the other way around, a balanced signal to an unbalanced input. Now let's actually go ahead and get this cable soldering. Now I'm going to take this cable and I am going to chop off the end of this. So I'm going to back up here just a little bit. There we go. So I have my cutters and I'm going to chop this thing off. Now we can see on this cable that we have our jacket, and then we have this kind of braiding material that's right here, and then we have our two conductors, a blue and a red. Now, when we're soldering a cable on here, we need to strip back some of this jacket to expose the wires so we can actually solder it. Now, with Neutrik connectors and Switchcraft connectors, you need to put the end piece on the cable before you solder it. This is really important because if you don't do this, then you're going to have to unsolder that and put this end on and then resolder it later. And I can't tell you how many people have done this. I've done it so many times by accident. Other people have done it so many times as well. So all we have to do is take this and put it on our cable and push it all the way through. Now the strain relief, we'll notice that there is a slit on this strain relief, so we can actually plop this over top of a cable. But if you want to, you can go ahead and put this on our cable as well and just push that to the end like so. So at this point, we have this cable. The next thing that we want to do is grab a knife. Now I'm going to strip off about 1 inch, or for you European folk, about 20 centimeters of shielding or jacket off of this cable. And so what I'm going to do is I'm going to get about that much and I'm just going to bend it like this. Now what we want to do is we want to take this knife and we want to cut into the cable lightly. Now when you have a very sharp knife, it's just going to start opening up. Now the benefit of bending this is that it will just start cutting into this like butter. And so we can see that already I have sliced into the jacket and exposed the shield. Now what we don't want to do is we don't want to break any of this shield connections. So we don't want to cut these wires. And so by bending this, it's just creating it so that once you open it up with this knife, it will just kind of open up. And so once we have that set, I'll rotate the cable and then I'll bend this cable right here so we can see that I'm now going to take my knife and I'm just going to continue this around like so, and then continue this around. And at this point, we can line up the two ends just like that. And so at this point, we can see that this jacket is able to be removed. And so we can just pull this jacket right off. And so at this point, then we have a couple conductors here. So we have our braid that we have right here. And so this would be our shield. And so what you can do is you can take a knife or a screwdriver, and you're just going to peel this back. Now we can see that this is a really old cable because this copper is a bit tarnished. And so if I was choosing if this was a cable that I wanted to salvage or not, this would be a cable that I would not want to salvage because this copper is a little bit tarnished. And so for today, I'm going to go ahead and solder this anyway. And so I'm just going to go ahead and take this shield and I'm going to twist it around. And so I'm going to continue twisting this until it is all twisted towards the end. So I'll just continue twisting it around, twisting it around, twisting it around. And at some point, you're going to have kind of this really ugly end. And so what you can do here is you can choose to snip that off, or we can snip it off after we tin this end. Now, we also have this filler. Now, every XLR connector, or sorry, every XLR cable is going to have some sort of filler. It's going to be a twine like this, or plastic or paper. And what we can do is we can either take a knife or some diagonal cutters, and we can just snip this off. And so I'm just going to snip that off without nicking any of the wires. And so then we can just take this and we can toss it away. Now, at this point, I have my 3 conductors here. So I have my ground, I have my red, and my blue. Now, some wires are going to have a red and a white, or a red and a black, or whatever. Now, the goal is to open up this connector on the other side and verify what colors they're being plugged into. Now, if you don't happen to have done that like I did not note which ones they were, we can just use a continuity tester with my multimeter to do this. So what I'm going to do now is I'm just going to strip off the rest of these wires. Now, to do this, I'm just going to use my wire stripper. This is my wire stripper, and we can see that there's a bunch of numbers. We can see solid, AWG, and stranded on the other side. Now, this is gauge of wire. AWG stands for gauge. So if we have a 12 gauge stranded cable, that's going to be the size that it would strip off of a 12 gauge stranded cable. Now, if you don't know the gauge of the wire, you can usually look on the outside of the cable, and there's typically going to be some words on it. In this case, it doesn't say. So what I'm going to do is I'm just going to take a look at the cable and just size it up and see. And so I'm going to use a 26 gauge on this stranded to go ahead and take this off, and we will see how that is. So what I'm going to do is I'm going to take this all the way down to about 1/4 of an inch, or about 8 millimeters here, and we're just going to punch that down, and we are going to strip this off. And it should strip off cleanly just like that. So there shouldn't be any wires left inside of this. Sometimes there are. So if you do happen to choose a hole on your wire stripper that's too small, then it is going to pull out some of the strands. Now, the next thing that we want to do is, once we have this, is we want to just go ahead and twist this around and just twist that so that it is nice and straight, like so. Now then, the next side, we're just going to do the same thing. And while I have this here, I'm just going to shorten these up by cutting off the end. And so I'm just going to go here and trim off some of this because I trimmed a little too much. There we go. Okay. So we have those 2 cables, and I'm just going to pull them away, and we are going to then strip this piece here. And there we go. So I'm going to press down and then pull out like that. And then we are just going to twist this together. Now, the twisting is important because it makes it easier for the solder to grab hold of the cable. If you don't twist them together, then when you're soldering, it's just kind of going to go everywhere. And so we have these 3 conductors here. Now, what I'm going to do is I'm going to grab my multimeter, and we're just going to go and take this multimeter, and I'll zoom out here. We're going to take this and turn this to our continuity checker. And at this point, when I touch these together, it makes a sound when there's continuity. And so what I'm going to do is I'm just going to look into this connector and find my pin 2, which is right here. and see which it connects to, which is the red. So this is soldered correctly. So we can see that I have this on pin 2, and this is making sound when it gets to the red. So this is correctly soldered on the other end. So what we're going to do now is I'm going to get my soldering iron up and running, and I'm going to first tin these wires, tin the connector, and then solder them together. So let me go ahead and get my soldering iron going. And so here's my pine sol, and all I have to do is just turn it on, and we can see that it's going up and hotter and hotter. Now, every type of solder is going to have a different melting temperature or different soldering temperature that you need to reference. And so this leaded solder that I have here, 380, 390 is going to be perfect. So I have this set to 390 degrees Celsius. Now, if you have some gaff tape, this is helpful, or what I usually do is I grab my pair of cutters and I put this right here so that it just lays this cable up slightly as I am tinning. And I'm going to get this in a good spot so you can see what's going on here. There we go. Okay, so now this soldering iron is exceptionally hot. So we can see that it's 390 degrees Celsius. Now, if we grab my solder and I touch it to the tip of this, it is going to melt onto the tip. And then we can see that it is starting to smoke. Now, we want to have a solder tip that is clean. And so what we want to do is we want to use this to clean our soldering tip. And so what we can do is we can add some solder and we can flick it off, and we can see that that little piece just went down there. And we can just take this soldering iron and just scrape it against this copper. The other thing you can do is you can just take this and stick it in there and wiggle it around. But our goal is to get the tip of the soldering iron nice and clean. And so we can see that that is a clean solder tip now. And at this point, then we want to go ahead and add some solder to this, so that our tip of the soldering iron is smoking. We want to have a smoking soldering iron. At this point, we take this soldering iron, we put it underneath the wire, and let me zoom in here so you guys can see this. There we go. And so we want to have our smoking soldering iron, so I'm going to add a little bit of solder, and so we can see that that's smoking. We go ahead and place this underneath the wire, and then we tap our solder to the wire, and then we bring our soldering iron up as we are tinning this. Now, tinning this basically just adds solder to this cable. And so we can see that that cable has more silver on it than just the copper. And that is how we can correctly solder this together to our connector. And so then we have our next one, and we can go ahead and clean off. Since I'm going a little slow here, I can go ahead and add some solder to this. I can flick it off, and then I can go ahead and solder this cable. Now, we don't want to put too much solder, and so we can see that on this cable, I'm just going to go ahead and add in a whole bunch of solder here. And so we can see that there is a big bulge here on that wire. And we don't want to have a ton of extra solder on this cable. We want to be able to see kind of the twist like it is down here. And so just keep that in mind. Don't add a ton of solder, but don't add too little. And so I'm going to go ahead and do the shield here. Now, when we're doing the shield here, I do leave a little bit of this untinned, and that way it is able to be bent still pretty easily. If I take this and I add tin all the way to the end, then it's going to make it so that, one, this cable could burn and melt into this and then bridge these two cables together. And then the other reason is I want this to be flexible. So when I'm tinning the shield, I am looking to just go out about 5 millimeters from the end, or 1/4 of an inch from the end and out. So I'm going to go ahead and clean this tip off like so. And then I'm going to take my solder and add some solder there, flick it off, and we can add. Now, as you are tinning this cable, the solder will follow where the heat is. And so sometimes if you are soldering a cable, you will need to put the solder in between the cable and the soldering iron. So basically just like right there. And by doing that, it'll make it so that the heat will transfer through the soldering iron to the wire. You just want to make sure that when we take this soldering iron away, that there's still solder attached to the cable. Okay, so this is a tinned cable. So as we can see, those wires here have silver on them, except this one has a little bit of copper left. And so this is perfect because that means that I can then bend this. Now, if it is a tinned cable, I can go and bend this, but it's just a little bit harder to bend. And so at this point, what I'm going to do is I'm going to line these up and I'm going to trim these off to about right there. And so I'm going to grab my diagonal cutters and I'm just going to give a nice clean edge just like that. So to do this like that, so we can see that I have my tinned wires there. Now, the next thing that we want to do is we want to grab our other end of our cable and make sure you grab the correct end. And this is the portion that we want to solder. And so on this side, we can see that there are labels here of which pins. So we can see 2, 1, and 3. And so with this, we also want to tin this. And so I'm just going to, sometimes you have to get a little bit creative with how you hold things. All right, so we can see that I have my 3 ends there. And so we're going to do the same thing with our solder, and we are going to tin these ends because tinning them before adds a little bit of extra solder so that the heat can transfer into both ends and then be soldered correctly. So I have my soldering iron. I'm going to go ahead and clean the tip, and I'm going to add some solder to my soldering iron, and then I'm going to flick that off. We now have a smoking soldering iron. I am then going to go ahead and add heat and then add solder. And so we can see that I'm just adding in some solder here, just like that. Now, I don't want to add too much solder at this point. I just want to add a little bit. And then on this one, it's moving on me. Okay. All right, so we can see now that those 3 pins have a little bit of solder, which is perfect because that's what I want when I am soldering this. Now, I'm going to just grab some tape here and tape my connector into this. A little tip. E-tape works really well for this if you're ever doing this. Okay. There. So now that connector is not going to go anywhere because I've taped that. So what we want to do is we want to find where our numbers are. So 2 is here, 1 is there, and 3 is here. So remember, shield, positive, negative. And so at this point, I'm going to go and find my cable, and I'm going to bend these so that it's going to land correctly. And so I'm just going to take my red, and I'm going to bend it over. I'm going to take my shield and bend it towards the 1, and my blue is going to go to the 3, just like that. And so at this point, then what I can do is I can grab some diagonal cutters or some pliers if I want to, and I'm just going to bend this so that they're going to go straight in. So I'm not cutting, I'm just bending it. So we can now see from this side, we can see that those line up pretty nicely. And from the top, they're also lining up pretty nicely. And so at this point, what we can do is we can just go ahead and line this up just like that. And then what we're going to do is we are going to solder this in. And so I'm just going to tack one end of these wires in, and then I'm going to then go and solder the rest of them and add in some more solder to make sure that that solder connection is correct. So we're going to go ahead and start with the ground on pin 1. And so I'm just going to go ahead and add a little bit more solder because I'm just going to kind of tack this in here. And so I have this end hot right here, and I'm going to keep this hot, and I'm going to put my wire in, and once it is lined up there, I'm going to apply pressure with the soldering iron, and it's going to melt both the solder of the wire and the solder of the connector. And then I'm going to keep my hand very still so that this cools by itself. I'm not going to blow on it. I'm just going to remove the heat and let it cool. And as we can see, that is now connected. And so we can see that that connection does need a little bit more solder, but that is connected. Now I'm going to then move on to the other wires and get those connected as well. So I'm going to add a little bit more bend to my blue wire, like so. All right, and get this back in this little spot here. All right, we're going to go for the blue wire next. And I'm going to use the soldering iron to kind of push that wire in there. I'm then going to add solder. And I'm going to let it sit there, remove the soldering iron, and let that cool by itself while I'm not moving this. Now, if you blow on it, it's going to create the solder into a different structure while it's drying or cooling, and it's just not going to be as good of a solder connection. Also, if you just simply tap this soldering iron and touch it barely, it's going to do what's called a cold solder joint, meaning that it is connected, but it's not connected correctly. And so we want to make sure that we're leaving this soldering iron on there long enough to melt the solders of both the wire and the connector together, and then let it cool naturally. So now it's time to do this one here. And so I'm going to just go ahead and add in heat. I'm going to add in some solder. Perfect. Gonna let that cool. And then I'm gonna go do the ground again, add in a little bit of solder. Perfect. Okay, so at this point, this is soldered. So we can go ahead and turn off our soldering iron or set it to the side or unplug it. And at this point, we can go ahead and put this back together. And so I'm going to go ahead and take this out. And so at this point, I can go ahead and check this with a cable tester, even with this completely disconnected. So I can go ahead and take my XLR connector, I can turn this on to cable tester, I can put this on this side, and we can see that on this, pin 1 lines up with pin 1, pin 2 lines up with pin 2, pin 3 lines up with pin 3. Now, if you have a cable that is soldered incorrectly, then it's going to show up differently on this. And so I'm just going to take a piece of wire and I'm going to bridge these two connectors. And so we can see that we have a bridge happening between our pin 3 and our pin 1 on both sides. Now, if I was to reset this, I can make the same thing happen with pin 2 and 3, just like that. So this is what a bridge cable looks like. Is that pin 1 is connecting to pin 1 on the output. Pin 2 is connecting to both pin 2 and pin 3. Same thing with pin 3 is connecting to pin 2 and 3. And so this is what a bridged cable looks like. So the next thing that we would do is we would take this and we would put our strain relief all the way up. And I'll scoot back just a little bit on this guy. There we go. We just put our strain relief there. And then we go and grab our Neutrik end, and we put that right in, line that up, and we can take our end of this and screw this together. And there we go. Now we have this little 10-inch XLR cable that's not going to be super helpful for me. Now, I hope this video was helpful for you. If you do have some XLRs that are broken, grab a soldering iron, grab some solder, and try to solder it. It is already broken, so you can't break it anymore. And so grab that cable, grab a soldering iron, try to do it, use a cable tester, see how you did. If you happen to do it incorrectly, do it again, and do it again, and do it again. And chances are you have a whole closet full of XLR cables that have bad ends or a bad cable, and so you can go and resolder a bunch of cables and put a whole ton of cables back into your inventory. There have been churches that I have worked at previously where there was a whole box of probably 40 XLR cables throughout the years that just have gone bad. And all I did was grab them and soldered new connectors on them or resoldered the connectors that were already on the cables on them. Took some sections out, shortened some cables, and I put 40 XLR cables back into service that I didn't have before. Now, for a church that is on a budget, that's a lot of XLR cables, and that's a good amount of money that you can save your church or your venue in just repairing some cables. Now, if you do happen to have any questions, or there's a video that you're hoping that I would make on, soldering or any production equipment that's out there, please post that in the comment section down below, as I'm always reading through those comments to find videos that are gonna be helpful for you. If you haven't already, make sure to check out my website at drewbrashler.com. Otherwise, I hope you have a great day.